let us see the third problem. Design an algorithm to find the nth Fibonacci integer. The Fibonacci integer is defined using the sequence 0, 1, 1, 2, 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8 21, 21 plus 13 34, 34 plus 21 55, etc. This is the Fibonacci sequence. First two numbers are required, starting from 0, 0, then next number 1. Adding these two, right, we have the next integer 1, 0 plus 1, 1. And taking the last two integers, right, this 1 and 1, 1 plus 1, this results in 2. Then taking the next or last two integers, 1 plus 2, this results in 3. Taking the last two integers, 2 and 3, adding 2 plus 3, 5. And this 8 is equal to 3 plus 5. And this 13 is equal to 5 plus 8. And this 21 is equal to 8 plus 13. 34 is equal to 13 plus 21. And 55 is equal to 21 plus 34. This is the Fibonacci sequence. To generate the Fibonacci sequence, we need to initialize two variables. For example, a is equal to 0 and b is equal to 1. Having this initialization, a is equal to 0, b is equal to 1, we can find the next number in that sequence, writing c is equal to a plus b. Assuming right 0 is the first number and b is equal to 1 is the second number, we can have right the third number. For example, for I is equal to 3 to n do. When n becomes 3, right, the third number is obtained as c is equal to a plus b. After finding the third number, we need to update the values of a and b. So the value of b, right, b is updated to a and the value of c is updated to b. A is equal to b, b is equal to c. These statements, right, should come under the for loop. For I is equal to 3 to n do, c is equal to a plus b, and updating the variables a and b, a is equal to b and b is equal to c. When the control comes out of the for loop, we need to return a value of c. Return c. The updated variable c, updated value of a variable c returns the nth Fibonacci number. So the nth integer in that sequence is assigned or computed in the variable c. Let us write the algorithm and check if the algorithm produces the correct result for the given value of n. First, let us design the iterative algorithm. Iterative algorithm. To design the iterative algorithm, this initialization is required. A is equal to 0, b is equal to 1. Then Continuing this for loop, we have 3 executable statements. C is equal to A plus B, then A is equal to B, and B is equal to C. Since A, B, C, A is 0, B is 1, C is updated to 0 plus 1 is equal to 1. Next value of A, right, this B should be right assigned to A. That's what A is equal to B is written. The value of C, right, should be assigned to B. So we have written B is equal to C. This one is coming here. So that next, right, when C is equal to A plus B is evaluated, 1 plus 1 becomes 2. This is the iterative algorithm or iterative logic to design the to compute the nth Fibonacci integer. Let us design the algorithm. Say Fibonacci, the parameter is n. That means we need to find the nth integer in that sequence. Assuming n is equal to 1, returns a value 0. This is n is equal to 1, returns a value 0, and n is equal to 2, returns a value 1. If we need, right, we can make a comment here. What is a comment? N represents the n represents the nth Fibonacci number to be obtained. The algorithm returns the nth Fibonacci number. Let us have a Fibonacci of 1. 1 is 0. Fibonacci of 2 is 1. Assume, right, the value of n is greater than or equal to 3. N greater than or equal to 3. Since we already initialized the first two numbers in the sequence, for example 0 and 1, if you input n is equal to 3, this 1 is expected. N is equal to 4, or 2 is expected. N is equal to 5, this 3 is expected. So assuming here n is greater than or equal to 3, how to write the statements? Initialization, A is equal to 0, B is equal to 1. A is equal to 0, B is equal to 1. For I is equal to iteration, 3 to n do. For I is equal to 3 to n do. The computation is, say C is equal to A plus B, then A is equal to B, B is equal to C. For ends with loop or write end for here, end for, then after for return a value of C, return C, opening curly brace, ends here, closing curly brace. This signifies the end of Fibonacci. This is the iterative approach. Iterative algorithm to find the nth Fibonacci number where n is greater than or equal to 3. Let us check the result. Suppose this is first, second, third, 3, 4, 5, 6, 7, 8, 9, 10. Let us input the value of n as 10. Let us trace the algorithm. Find Fibonacci of 10. That means find the 10th number in the sequence. To evaluate the value of Fibonacci of n, right, Fibonacci of 10, clearly the formal parameter n receives the value 10, n is equal to 10. We need to construct the columns to make the trace easier. The columns required are A, B, C is equal to A plus B, then the value of I, checking if I less than or equal to n. These are the necessary columns required, column A, column B, then value of I less than or equal to n, and C is equal to A plus B. Initially, right, what is the initial value of A and B? A is 0, B is 1. A is 0, B is 1. Before the control enters into the for loop, A 0, B 1, C is equal to A plus B, I less than or equal to n, right, put hyphen. So before the control enters into the for loop. Now the control enters into the for loop. Control enters into the for loop. What is the initial value of I? I is equal to 3. Now I is 3. Checking if 3 less than or equal to n. 3 less than or equal to 10. 3 less than or equal to 10. Condition is true. If the condition is true, the statement to be executed is C is equal to A plus B. So updating the value of C is equal to A plus B, 0 plus 1 is equal to 1. Now the variables A and B are updated. A is equal to B, B is equal to C, right? So updating A is equal to B, A becomes 1, B is equal to C, B becomes 1. Then after this update, control goes to increment the value of I by 1. Next the value of I is incremented by 1. I becomes 4. Checking the condition if 4 less than or equal to 10, condition is true. C is equal to A plus B. Current write C, A plus B. 1 plus 1 is 2. Now A is equal to B, A becomes 1, B is equal to C, C is 2, B becomes 2. Then after the update of A and B, I is incremented by 1, I becomes 5. 5 less than or equal to 10, condition is true. Now C is equal to A plus B, 1 plus 2 is equal to 3, A is updated to, B is updated to 3. Then I becomes 6, 6 less than or equal to 10, condition is true. 2 plus 3 is evaluated, C is updated to 5. Next A becomes 3, B becomes 5, I becomes 7, 7 less than or equal to 10, condition is true. 3 plus 5 is updated in a variable C, 3 plus 5 becomes 8. A becomes 5, B becomes 8. Then I becomes 8, 8 less than or equal to 10, condition is true. 5 plus 8, this becomes 13. Then A becomes 8, B becomes 13. I is incremented by 1, I becomes 9, 9 less than or equal to 10, condition is true. Then 8 plus 13, C is updated to 21, A becomes 13, B becomes 21, I becomes 10, 10 less than or equal to 10, condition is true. Now 21 plus or 13 plus 21, 13 plus 21, 34. A becomes 21, B becomes 34. I is incremented by 1, I becomes 11, 11 less than or equal to 10, condition is false. So for loop completely executes its execution, right? C is equal to A plus B, A is equal to B, B is equal to C. C is equal to A plus B, then what is the next statement? A is equal to B, B is equal to C. Here C is equal to A plus B, A is equal to B, B is equal to C. Then I is incremented by 1, I becomes 11. Checking 11 less than or equal to 10, right? Condition is false. Control comes out of R. Then the next executable statement is return C, right? Finally, return C. What is the updated value of C? C is 34. 34 is returned here. So it indicates the 10th number in that sequence is 34. Let us verify what is the 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th number is 34. So Fibonacci of n, substituting n is equal to 10, the 10th number in that sequence 34 is obtained. Having the initialization 0, having the initialization 0, 1, the next number is obtained 0, 1, next number is 1, 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8 21, 21 plus 13 34, 34 plus 21 55, etc. This is the first and second numbers, third number, fourth number, third number is 1. So when I becomes 3, right, the third number is 1 here. When I becomes 4, the fourth number is 2. Then when I becomes 5, the fifth number is 3. Here fifth number is 3. When I becomes 6, the sixth number is 5. When I becomes 7, seventh number is 8. Eighth number is 13. 8, 13. Ninth number is 21. 9, 21. 10th number 10, 34. 10, 34. Likewise, when n becomes 11, here when I becomes 11 here, the 11th number in that sequence is 55. So the algorithm here returns a value 34. 34 is nothing but the 10th number in the sequence. So clearly the iterative approach, this iterative algorithm finds the nth Fibonacci number in the sequence where n is greater than or equal to 3. The same algorithm can easily be converted to the recursive approach. Now let us design the recursive algorithm to find the nth Fibonacci number. Design a recursive algorithm to find the nth Fibonacci number. Design a recursive algorithm to find the nth Fibonacci number. The Fibonacci number sequence is defined 0, 1, 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, 34, 55, etc. We need to define the recursive relationship. Since the third number is obtained by adding the previous two numbers, or in general the ith number is obtained by adding the previous two numbers. In case, right, if you write the nth number, right, fib of n is obtained by writing fib of n minus 2 plus fib of n minus 1, assuming fib is a function. Nth number is obtained by adding the previous two numbers, fib of n minus 1 plus fib of n minus 2. We need to define the termination conditions. To terminate the recursion, we need to write the recursive relationship, right? This one, this recursive relationship should have the proper termination. To find the nth Fibonacci number, we have the recursive relationship fib of n is equal to fib of n minus 2 plus fib of n minus 1. The previous two numbers are added. Since we are in the nth position, previous position is n minus 1 and the previous, right, one more position is n minus 2. The corresponding numbers are added to have the nth Fibonacci number. This recursion should have a proper termination. Since fib of 1 is 0, assuming, right, the first number in that sequence is 0 and second number in the sequence is 1, fib of 1 is equal to 0 and fib of 2 is equal to 1. These two equations are acting as the termination conditions. Termination conditions. So combining the termination conditions here, writing fib of n is equal to a fib of n minus 1 plus a fib of n minus 2. This is the case when n is greater than or equal to 3. And fib of 2 is equal to 1 when n is equal to 2. 0 when n is equal to 1. N is equal to 1, the value is 0. N is equal to 2, the value is 1. This acts as a recurrence relation. This is the actual recurrence relation to find the nth Fibonacci number. Fib of n is equal to fib of n minus 1 plus fib of n minus 2. This is true when n is greater than or equal to 3. Else, you need to check these proper termination conditions so that the algorithm can be easily returned. For example, a recursive algorithm of fib of n. This is a recursive algorithm which finds the nth Fibonacci number using recursion. Nth Fibonacci number using a recursion. What we have to assume? A fib of 1 is 0, fib of 2 is 1. Then n greater than or equal to 0. This is the positive integer. N greater than or equal to 0 and integer. This is the input restriction. Now writing the recurrence relation, if n is equal to 1, return 0. If n is equal to 1, then return 0. Else if n is equal to 2, then return 1. So these two equations are implemented. If n is equal to 1, return 0. If n is equal to 2, then return 1. If n is not equal to 1 and not equal to 2, right, then else write a recurrence relation or recursion here, return. What we have to do? We have to write this computation, fib of n minus 1 plus fib of n minus 2. Writing here, return fib of n minus 1 plus fib of n minus 2. That's all. If else, then and if, for the outer if. If n is equal to 1, the statement to be executed is return 0. If n is equal to 2, else if n is equal to 2, the value to be returned is 1. Else return this expression, fib of n minus 1 plus fib of n minus 2. If ends here, end if, opening curly brace, closing curly brace. This is the end of fib of n. This is the recursive algorithm. A recursive algorithm to find the nth Fibonacci number, where n is greater than or equal to 3. In case if you put right n is equal to 1, no problem, algorithm returns a value 0. If n is equal to 2, no problem, here algorithm returns a value 1. For n is greater than or equal to 3, right, the algorithm finds the corresponding nth number in that sequence. Let us verify the correctness of this algorithm. Let us find the value of fib of 5. A fib of 5, suppose for n is equal to 5, the algorithm likes to return a value, a fib of 5. Checking if fib of n, right, so clearly n receives a value 5. Checking if n is equal to 0, n is not equal to 0, n is not equal to 1. So algorithm returns fib of n minus 1 plus a fib of n minus 2. 5 minus 2 is 3. Then further write a fib of 4. A fib of 4, right, computes fib of 3 plus fib of 2 plus a fib of 3, right. Let us trace later. Let us complete the first left hand side recursion. Fib of 3 plus fib of 2. Fib of 3, what happens? It evaluates fib of 2 plus fib of 1 plus fib of 2 as it is. Fib of 2, what is the value of fib of 2? Fib of 2 is 1. This is 1. Fib of 1 is 0. 1 plus 0 plus fib of 2 is 1. 1 plus 1 or 2. Here the complete expression is evaluated to have a value 2. Then a fib of 3. How fib of 3 is evaluated? A fib of 2 plus fib of 1. Fib of 2 is 1. Fib of 1 is 0. 1 plus 0, right? 1 is returned here. Then here a 2 plus 1. 2 plus 1 is 3. Return 3. Fifth number is 3. 0, 1, 1, 2, 3, 5, etc. This is the first number initialized. Second number is initialized. This is the third number. This is the fourth number. And this is the fifth number. As we traced earlier using the iterative approach, the fifth number in that sequence, when I becomes 5, C holds 1 plus 2 is equal to 3. The fifth number in that sequence is 3. So here the same, right, the fifth number in that sequence, fib of 5, the algorithm returns a value of 3. So the algorithm, right, correctly implements the recurrence relation. Proper termination conditions are satisfied. This recurrence takes more than one termination conditions. In general, a recurrence relation may take more than one termination conditions. In factorial, we have only one termination condition. When n is equal to 0, 0 factorial, the value to be returned is 1. Here we have two termination conditions, a fib of 1 and a fib of 2, right, two termination conditions, and this is the recurrence relation. Even, right, the recurrence relation is solved, right, fib of n is equal to fib of n minus 1 plus fib of n minus 2, right, extending the recurrence relation wherever, right, a fib of n minus 1, right, fib of n minus 1, you need to substitute the value of here n as n minus 1 in the left hand side. Here n minus 2 means you need to substitute the value of n as n minus 2, right. So if we apply the substitution method recursively, right, until the recursion disappears in the right hand side of the equation, finally we have the nth Fibonacci number. A Fibonacci of 5, right, this is computed using the recurrence relationship. Finally the fib of 5 returns a value 3, the fifth integer in that sequence is 3. Likewise, if you put, right, a fib of 10, putting n is equal to 10, we need to evaluate here a fib of 9 plus fib of 8. Fib of 9 and fib of 8 are repeatedly evaluated using the recursion, and finally, right, we have the value, that value to be returned is equivalent to 2, right, the fib of n, where n is 10, fib of 10 is evaluated and the value is returned from the algorithm. So whichever is the iterative algorithm, right, as we designed here, iterative version of finding the nth Fibonacci number, algorithm Fibonacci of n, or the recursive algorithm as we designed here, algorithm a fib of n, whichever is, right, either the iterative algorithm or the recursive algorithm, both algorithms are producing the correct result. We have verified the correctness of the algorithm. So algorithms can be designed, right, using the iterative approach as well as a recursive approach. In the case of recursion, we need to ensure that the recurrence relation that should be defined carefully, and we need to define the proper termination conditions. Proper termination conditions and recurrence relationship should be defined to ensure the logic of recursion.